Yes, hello. Is this audible, Samya?
Yes, ma'am.
Alright. So, Samya, we had discussed electric charge and we had started with methods of charging. Yes or no?
Yes, ma'am.
Okay. So, we had discussed first and second method, I think. We have done it till
Yes.
charging by conduction. Alright.
Yes.
See, in charging, just a quick recap, in charging by friction, the frictional force, when two bodies are rubbed together, the frictional force helps in generating or transferring of charge. In case of charging by conduction, what happens? The two bodies are not moved. The two bodies are just kept in contact and the charge gets transferred. If the bodies are identical, the way we had seen the cases of sphere, if the bodies are identical, then the charge gets distributed equally. So we had seen till here. Now see, charging by induction is what? If I have this conductor with me, this conductor, which you are able to see, it has positive charges, it has negative charges. So if I say the conductor has equal amount of positive charges, equal amount of negative charges. So can I say the body is neutral, or will it be positively or negatively charged?
It's neutral.
Neutral, it will be neutral. Now, induction is basically a method which is known as this temporary electrification. See, why is this temporary electrification? Because temporarily, for some time, for some duration of some time, we separate the positive and negative charges. If this is my conductor and I bring up a glass rod, and this glass rod is positively charged like this. So if this glass rod is positively charged, just tell me one thing. What kind of charges will it attract towards itself?
Negative charges.
Negative charges. So slowly and slowly what will happen? All these negative charges, these will get attracted towards the glass rod. Why? Because the glass rod consists of positive charges. So see, ultimately what will happen? You will get such a condition where all the negative charges are at one place and all the positive charges are at one place. This is how you have separated two charges. So see, till the time I'm holding the glass rod, that till that time only the negative charges are kept and the positive charges get separate. As soon as I will remove this, as soon I will remove the glass rod, what will happen? All the positive charges and the negative charges, they will recombine with each other and it will again become neutral. That's why we have used the word temporary, because it is this electrification is till the time the glass rod is present. Even if I take negative charges on the rod, just the opposite thing will happen. If I bring up the glass rod with negative sign, instead of attracting the negative charges, it will attract the positive charge in this manner. Until the time I'll be holding the negative charges, means the glass rod, till that time the positive charges will be separated from the negative one. Now see, this charge that is present on the glass rod, which is performing this method of induction, these charges present on the glass rod, these are known as inducing charges. This is known as inducing charge. And all the charges that get separated because of the presence of this glass rod that we have, these charges that are electrified temporarily, these are known as induced charge. So we have inducing charge that induces a charge, and the charge that gets induced is called induced charge. And the glass rod means whatever object you are having to bring up the charge, that is known as inducing charge. So see, the definition of induction becomes what? When a charged body is placed near a conductor, it induces near a neutral conductor. It induces charges due to the redistribution of electrons. So for induction, what did we do? We took up the neutral conductor, we brought up a glass rod with a charge that we wanted to separate it with. And then temporary electrification is done, and if I want the neutral body back, I can remove the inducing charge, and then the charges will recombine and the body will again become neutral. This was the third process that was left on that day. Is this clear?
Yes, ma'am. Clear.
So just note down this, Sanya.
Okay, ma'am. Yes, ma'am. Then. Yes, ma'am.
Okay, Sanya. Now see, before we move on to the question on how questions on induction come, just remember one phenomena that you are already aware of. The phenomena of earthing. See, in case of earthing, what happens? You have the conductor. Now, electrons flow either from the body to the earth or from the earth to the body. This process of transfer of electrons from the body to the earth or the earth to the body, this is known as earthing. Now, see, if electron flows from whether electron flows from the body to the earth or from the body, that depends on what kind of charge this body is carrying. If I say the body is negatively charged, then excess electrons are present in the negative charge, and as we have discovered, only it's the electrons that gets transferred, not the protons or positive charges. So what will happen? Negatively charged body has the excess of electron which has to be removed and transmitted to the earth. So these negatively charged bodies will transmit electron from the body to the earth. And whereas if instead of negative, you have it as the positively charged body. So what will happen? Electrons from the earth, these will go back to the body to neutralize it. Basically, the purpose of earthing is what? To neutralize the object. If I have minus E, so negatively charged body is there. So if this minus E flows out and goes into earth, the body will be left again neutral. Or if it is having plus E, means positive E, if one electron minus E comes to it, then it will again be zero, because minus E plus E, that will be zero. So this is the purpose of earthing whenever you want to eliminate the charge. Is this clear? Earthing?
Yes, ma'am. Clear.
Okay, so just sound earthing as well as write this question. All right, then I'll teach you how to solve such kind of question, because these questions have occurred in your NCERT as well. All right.
Okay. Yes, ma'am. Done.
Now see, what's your question? The question says that you have to make this isolated sphere as positively charged sphere. So since there are no excess charge present, it means this is a neutral sphere right now. Right now, this is a neutral sphere. So see, what will happen? We have to make it a positively charged sphere. If I take this sphere, this is an insulating stand. This is an insulating stand. So if this is the sphere, this is the insulating stand. Now, if I bring up the glass rod, all right, this is the glass rod that I have brought up. If I say this carries negative charge, so what kind of charges will be attracted at this end?
Positive charges.
Positive charges, perfect. Positive charges get attracted at this end, while the negative charges, they reside at the other end. This is what temporary electrification induction has been done. But now what will happen? As soon as I'll remove the glass rod from the sphere, what will happen? Both the positive and negative will recombine and again make it neutral. But our target is not to make it neutral. Our target is what? To make it positively charged. So I just want a method to eliminate all the negative charges so that only positive charges can there. So just now we have studied earthing. So if I connect it to the earth, earthing means like human body. If you are standing on the ground, on the earth, and your body gets excess of electrons, so those electrons pass on from your body to the earth, because your human body is a conductor, good conductor. So that is only the process of earthing. So if this is the sphere that I have, this is the insulating stand. Now I have to keep the glass rod because otherwise this will be removed. Now see, positive charges are there. If I connect it to the earth, all the negative charges means electrons, these will get neutralized. Negative charges. Now only positive charge is present. If I now remove the glass rod, so there are no negative charge. There is not a single negative charge present to counterbalance and make it neutral. Now what will happen? Even if I remove the glass rod, the sphere consists of only positive charges. So it's not temporary now. Even if I now remove the glass rod, all the positive charges will get redistributed. This is redistribution of charges. Fine. So this is how you do questions on induction. You can get any case. You can get a case where you have to make it negatively charged. You have to keep it neutral only. So that depends on the question. Fine.
Yes, ma'am.
All right. Just note it down
Okay.
and let me know when you're done.
Ma'am, what is meant by insulating stand?
Insulating stand is there so that what will happen? Any charge won't flow through the earth. Insulator is what? The material that doesn't allow electron to pass through. So sphere is just kept on an insulating stand so that all the electrons do not flow right now. When we require the electrons to flow, we can perform the process of this earthing. All right. So just to keep the electrons intact, we always keep the metallic spheres or usually on the insulating stands. Fine.
Yes, ma'am. Done.
Done.
Yes.
Okay, Samya, I was saying that in this chapter also in your 12th standard whole completely, you will be requiring calculus. Now, this is the basic methods of charging. After this, there are very few properties of charges. Then we have to begin with Coulomb's law, then electric field is there. And then in your upcoming chapters also calculus is required and vectors. So let's just do a quick revision of calculus.
Okay,
If
ma'am.
it's fine by you.
Yes, ma'am.
Okay. So that then your calculus will get revised, then we can carry on the chapters because completely your basic integration, differentiation, and your vectors. This will be utilized. So we'll just do a quick recap. See, in calculus, so do you have difficulties in calculus?
Yes, ma'am.
Okay, okay. Then it will be clear. It's better to begin with it. See, in calculus, majorly you will be using two things. One is the function of differentiation. The other one is the function of integration. These are the two we have to discuss. Now, let's begin first with differentiation only. Now, first understand when do we have to use differentiation, when do we have to use integration. In case of differentiation, what happens? When we have to know, we have a very big quantity with us and we want to know a very small portion of it. So we differentiate it. We reduce the whole big thing into smallest infinitesimal small thing that helps us to know. So in that case, we use differentiation. Just briefly, if we discuss it. In case of integration, what happens is that if you have a small portion with you, a small quantity with you, and you have to expand it, you have to enlarge it, then you use integration. That's why we put limit from 1 to 2, from one quantity to another quantity. In differentiation, you reduce it. In integration, you expand it. So differentiation and integration are inverse operations. Like addition and subtraction, these are inverse operation. If you subtract one thing and you add, that will be same. Or like multiplication or division. If you multiply and then divide it by the same number, you get the number back. So similarly, in case of differentiation and integration also, both of them, these are inverse operation. Now, differentiation is what? This is basically change dependent variable whenever you have to differentiate variables. So this is basically change independent variable with respect to the independent variable. This means what? Understand. Whenever we have an equation, we have two quantities. Like if I write y is equal to 2x. So x is your independent variable. You can have any value of x, but y becomes dependent variable. Why? Because whatever value of x you will put, then only you will be getting the values of y. Yes, Gauri, it took you time to join. See, we had discussed right now only that charging by induction which was there. So that I'll help you. All right, after the class we will do. Right now what we are doing is in your 12th standard mainly your calculus is required, calculus and your vectors. So we are just brushing up our calculus and then we'll do a bit of vectors and we'll come back to electric charges and field. Fine? Yes, Gauri?
Yes, ma'am.
So yes, we were discussing differentiation. Fine. Now see, if I write dy by dx, whenever I write dy by dx, this means I am differentiating y with respect to x. If you have to differentiate y with respect to x, you write it in the form of dy over dx. Now, if I have a quantity x to the power n, and I'm differentiating this, let's say y is some polynomial which says this is a polynomial function. This is a polynomial function. Y is equal to x to the power n. The power of n is there. Now, if I differentiate it, means if I write it dy over dx, differentiating y with respect to x. So let me first put the value of y that I have. Y is what? X to the power n. Now, whenever you have such a case, y is equal to x to the power n, and you are differentiating it, the power comes out and gets multiplied. If your power is x to the power 2, 2 will come out. X to the power 4, 4 will come out. X to the power n, n comes out. So x to the power n is left. Now, on this exponential power that we have, just subtract 1. If, for example, y is equal to x squared, dy over dx will be what? Differentiation of x squared by dx. N comes out, means power 2 will come out, x to the power 2 minus 1. So this makes it 2x. So differentiating x square gives us 2x. Let's take more example. If we have y as x to the power 5 by 2, let's say. Now if I differentiate this, dy over dx, if I write, what is the general formula for x to the power n? Nx to the power n minus 1. So n comes out, means whatever is your power, 5 by 2 is the power. So 5 by 2, this will come out. This will come out means it gets multiplied by the whole term. Now what is left? X to the power 5 by 2. Just subtract 1 from the power that you have. So this will be what? 5 by 2, x to the power 5 by 2 minus 1 gives us 3 by 2. So this is 5/2 x to the power 3/2. This is how we write it. Even if you have power like x to the power half, y is equal to, if I have y is equal to x to the power half. Now see, this will be what? This will be dy over dx. The power comes, this becomes half. What is left? X to the power half is left. Just subtract 1 from it. This will be what? Half was already there. X to the power minus half it becomes. So this is how we differentiate basic quantities. So firstly, note down this. Note down till here, then we'll see properties of it.
Yes, ma'am, done.
All right, the basic properties of differentiation that will be utilized. The first property of differentiation is that if you have a constant function with you, if you have a constant function. So if I say y is equal to some constant, let's say k is some constant. So if I differentiate this k with respect to x or anything, this will be 0. Like if I give you example 3 and I ask you to differentiate 3. So immediately say this, the differentiation of 3, this will give you 0. Second property that we have is product of constant and variable function. Product of constant and variable function. Now this means what? If I have constant and a function as well, function of x, as in, so what will happen if you have such a case when you have a constant as well and you have the function as well? Firstly, constant comes out, means gets multiplied to the whole term, and then the way you differentiate whatever is left to you. For example, one example I am giving you, other example you both will try yourself. For example, if I say y is equal to 2x squared, so 2 is a constant, x square is a function. So if I differentiate dy over dx, see 2 is a constant, this will come out, this will get multiplied. Now how do I solve x square? This 2 comes, x to the power 2 minus 1. This is how we write, no, nx to the power n minus 1. So this will be 2x to the power 2 minus 1. So this becomes 4x. Fine. So you people also try this part. Y is equal to 3x to the power, or just try this, y divided by y is equal to 3 divided by x squared. Just try this part and send me your answer in the chat box. What is the final you are getting on differentiating this? Differentiate it, dy by dx. First, note down both the properties point and then try this. Y is equal to 3 divided by x square. So hint to solve is this, that instead of writing y is equal to 3 by x square, take x to the power 2 on the numerator side. So power gets negative. That will be 3x to the power minus 2. And then try the answer. Take 2 minutes, then I'll discuss it. So by now, I think properties you both have written down. You both must have written down. Yes or no? Or are you still writing the properties part? Shami and Gauri?
Yes, ma'am. Done.
Done, both of you?
I didn't done because I'm a little bit outside, so with some work, I will be home for it few minutes.
Okay. So if you want, you can write it down. We'll wait. Or if today you want to take the screenshot because you're not able to write,
I will take screenshot.
yes. Today you can. Okay, so Samya has got the answer. Let's discuss it. See, y is what? Y is 3, x will become x to the power minus 2. Now, y dy over dx means we are differentiating now. As I said, whatever is the constant term that will come out means that gets multiplied. So since 3 is a constant, just eliminate 3 from this. Now what is left? See, now x to the power minus 2 is left. Your n is now minus 2. N is not positive now. N is negative 2. So in x to the power n minus 1, put minus 2, n as minus 2 in this. This will be minus 2 x to the power minus 2 minus 1. So this gets what? Minus 2 comes out. X to the power minus 2 minus 1 you subtract it. So this becomes what? 2 gets multiplied with 3. This becomes minus 6x. Minus 1 minus 2 becomes minus 3. Is it clear? Now is it clear, Samya? What is the
Yes.
mistake that you
Yes,
did?
ma'am. Yes.
Okay. So you are able to identify the mistake. No, fine. Now, if you have addition and subtraction, till the time, just note down the solution for it. Now, if you have addition and subtraction, see, if you have addition and subtraction, how would you have to solve this? Let's say y is equal to x cube plus x square plus x. All of these are getting added. Now see, whatever way you are solving it for individual of them, just solve individually means differentiate all of them individually and at the end add them. For example, if you have this dy over dx, so this will be differentiation of x cube plus the differentiation of x square plus the differentiation of dx. This is how you will solve. If had it been subtraction, then minus sign would have come. You have to differentiate the way you have been differentiating each term. So if I differentiate this, so yes, Samya, you tell me, what will be the differentiation of x cube? Yes, try. X to the power n. So n comes out. So what will come out?
3.
3 will come.
3x square.
3x square. Perfect. 3x square will be here because 3 minus 1 is 2. Yes, Gauri, x square. How will you differentiate it? What will come?
Yes, ma'am.
If you differentiate,
Yeah.
Yes. What will come?
X square. 2x.
2x, correct. 2x will be there. And see, dx over dx, this is 1. So this is how you do whenever you solve differentiation. Whatever functions are there, just add in between them. I'll give you one more example. Just let's do that. Y is equal to 2x cube plus 3x square plus 2x. Let's do this. dy over dx. So 2x cube. Yes, Samya. Try it yourself. Firstly, the constant will be there. So the constant is what in the first term?
2.
2. Okay, so 2 is there definitely. Now, what is left? Differentiation of x cube. You've told me only.
Yes.
This is
3x.
3x square. So 2 gets multiplied by 3x square. Plus, yes, Gauri, you try. 3x square's differentiation is what? What will come out? What is the constant in this?
Which one?
In this term, 3x square, what is the constant?
3x square is the x square is constant. 3.
X square is variable. 3 is constant, correct.
0.
And differentiation of x square gives
2x.
2x, perfect. This gives 2x. And in the last, we are left with differentiation of 2x. So 2 is a constant. Now x to the power 1 is there.
1. Yeah.
Yes, so this becomes...
It is 2 only.
It is 2 only. This becomes x to the power 1 minus 1. That is x to the power 0. This can be written as 1. So final answer will be what? 6x square plus 6x plus 2. This is dy over dx. So just note it down, then let's revise integration. I think differentiation, this is enough for your physics. So just note these two down.
Yes, ma'am, done.
Then we have integration. This is the reverse of differentiation. The reverse operation of differentiation. For example, if I have, let's say, I have this rod with me. And I'm taking very, very small dx, infinitesimal small elements on it, dx, very, very small. And I say the length of the rod is capital N. And the length of the rod, this is capital N. Dx is a very, very small quantity. So if I integrate this small quantity, let's say this is the origin, x equals to 0, and this final is x equal to L. If I integrate it from 0 to this entire value L, length L. That gives me what? That will give me whatever is the length. What are we actually doing? We are taking very small elements dx and we are adding them. Dx, then dx, then dx, 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 dx. So all the dx added together will give me the length of the rod back. That is what we use as integration. Now, this was the theory part, but how we used it in numericals, how we solve it. If you are given a polynomial function, if you are given a polynomial function, this means you are given integration from x1 to x2, limits are there, x to the power n dx. This is the polynomial function given to you. If you have such a case, then what happens? Write x to the power n, 1 to the power. In case of differentiation, what did we do? We subtracted 1 from the power. Here, in this case, add 1 to the power. And now, whatever power you are getting after adding it, write the whole power in the denominator. Right now, I am getting n plus 1. So, the whole power is n plus 1 in the denominator. And then the limits are from x1 to x2. This is how we write. Now, further solving it, what happens? When we further solve it, 1 by n plus 1 is a constant. Regarding x to the power n plus 1, firstly use the upper limit. Upper limit is what? x2, and then write the power of whatever x is, power of x is given. Like here the power is n plus 1. So upper limit will be x2 to the power n plus 1. Add a negative sign. Then write the lower limit, x1 to the power n plus 1. This is a general way to write integration whenever you have. For example, if I give you a question where you have to integrate x square dx and limits are from 1 to 2. See, x to the power 2, first I'll write, I will add 1 to the power plus 1. Whatever is the power coming, 2 plus 1 is coming, so I'll write it in the denominator 2 plus 1. Limits are from 1 to 2. Now, if I take 2 plus 1 is what? This is 3. This will be 1 by 3. X is left with x cube. Limits are from 1 to 2. Now, as I've told you, 1 by 3 will be there common. Firstly, write the upper limit. Whatever power is of the x, that becomes the power of the upper limit. This becomes 2 cube minus. Then 1 cube. So this is what? This is 8 minus 1 divided by 3. This becomes 7 by 3. Fine. So just note it down first and then try this question and submit your answer. 4x cube dx, integrating it from 1 to 2. Okay. So first note down this. And then both of you submit your answer to that example that I've written. see how we'll solve this. If I have to integrate 4x cubed dx from limits 1 to 2, 4 is already a constant. I don't need to disturb that. Now what is left? X to the power 3 is left. So x to the power 3, I will add 1 on the numerator. I mean on the power. Whatever is the power, the whole term gets divided by it. Power was what? 3 plus 1. So the denominator also becomes 3 plus 1. Limits are from 1 to 2. Now 4 is there. 3 plus 1 also becomes 4. X to the power 4 from 1 to 2. 4 gets cancelled. 2 means upper limit, whatever is the power. What is the power? 4 minus lower limit to whatever is the power, that is 4. So 2 to the power 4 gives 16, 1 to the power 4 gives 1, that is 15. Is it clear now? 15? How can we get 15? Okay. So now at least you both should try. This is how we do. If I give you 4 by x square dx, integrate it from -1 to +1. Try this question. So see, Samya Gauri, how to solve this. First, take it as 4x to the power -2. Now you can solve x to the power -2. Instead of 3, I'm having -2. The way n becomes your -2, and limits are from -1 to +1. At least try this question. If you get stuck, ask me in between. If you get any answer, submit your answer in the chat box. Okay, so Samya has answered. Okay, Gauri, did you get any answer? How much? Okay, let's discuss it. See, if you write it as 4x to the power -2 dx, limits are from -1 to +1. Now 4 is a constant that will come out. Samya, you tell me what will be there on the power of x now?
-2 plus 1.
-2 plus 1, correct. This will be -2 plus 1. And same will be in the denominator, -2 plus 1. Limits are from -1 to +1. Is this clear?
Yes.
Now 4 divided by -2 plus 1 means what? -1. And x to the power minus 2 plus 1 means x to the power minus 1. This is limited from minus 1 to plus 1. So I can write this as minus 4. Okay, Gauri, you tell me what is after this? What will come after this?
Minus 4.
Minus 4 is there? Yes. Then upper limit
by lower.
No, upper limit you take plus 1, and then whatever is the power of x, write it as the power of it. All right. Then put a negative sign and do the same for the lower limit, minus 1 with the same power. Is this step clear to both of you?
Yes, ma'am.
Okay. Now see how to solve this. This is minus 4 is there. 1 to the power minus 1. I can write it as 1 by 1 so that it becomes positive. I can write it as 1 by 1 so that it becomes positive. Plus means because minus minus will become plus. 1 to the power minus 1. Again 1 by 1. This means minus 4. 1 plus 1 is 2. So this gives minus 8. Understood your mistake?
Yes, ma'am.
Okay, Samya, where did you exactly committed the error? Just tell me, then I'll help you with that.
Ma'am, I forgot the denominator.
Okay. Minus 2 plus 1. Fine.
Yes.
Okay. It's just note down this.
Yes, ma'am, done.
Okay. So this was about differentiation and integration. Now coming back to electric charge. In electric charge, we have studied methods of charging. First, we had discussed what is electric charge. So we had seen that electric charge is the basic property or intrinsic property of matter that gives rise to various phenomena. These phenomena can be electric force, these phenomena can include electric field. Then we had seen that nuclear forces are very stronger than electric forces. So nuclear forces do not allow the protons that are held in the nucleus to move out, whereas the weaker electrostatic forces allow the electrons to move out. So it is the transfer of electrons that occur, which is also known as charging of electrons. Now this transfer of electron or charging of electrons occurs by the three processes. One is charging by friction, other one is charging by conduction. Third one, which we have discussed, I have discussed it with Samya right now, that was charging by induction. So or you can take up the screenshots, and in brief it is, when in case of charging by induction, you have a neutral conductor with you. And if you bring up a glass rod which is positively charged or any inducing charge, that will attract the opposite kind of charge. For example, if I bring up a glass rod which is positively charged, that will attract all the negative charges. So at one point of time, what will happen? All the negative charges get separated from the positive charges. This results into electrification. Since I am keeping the inducing charge together, for the time being, the charges are being separated. If I remove the glass rod, what will happen? The positive charges and negative charges will recombine and become neutral again. So that's why we call it as temporary electrification, because this electrification is till the time when the inducing charge is present. So this method is known as induction, when we can separate positive and negative charges. So quickly take the screenshots, Gauri. Samia has already written them. So induction, this is the definition.
Yeah, done.
Just one more thing. In case of induction, you have to know this process of earthing. In earthing, what happens? Either electrons flow from the body towards the earth, or from the earth electrons move back to the body. Now, if whether electrons flow from body to earth or earth to body, that simply depends upon the nature of the body, what kind of charge the body is holding. If the body is made up of negatively charged molecules, then the electrons flow from the body to the earth. If the body is made up of positively charged molecules, if the body is positively charged, means is lacking electrons, has deficiency of electrons, then electrons from the earth come towards the body to make it back to neutral. So this process, this is known as earthing. Like if human body is a good conductor, if your body gets excess of electron and you are connected to the earth, means you are standing on earth without any insulator, then all the electrons flow from your body to the earth. So that is also an example of earthing. Then we had seen if we have to make an isolated sphere as positively charged sphere. In this, what we did, we had a neutral sphere with us. Then we brought this. This is what? This is the glass rod. Now the glass rod here, this is negatively charged. We have brought this glass rod as negatively charged. So what will happen? It will attract all the positive charges and the negative charges will come at one end. This is what we have studied about induction. Now, if positive charges are there at one end, I have to remove negative charges. Otherwise, what will happen? Positive charges and negative charges will balance each other. So the method to remove this electrons, I can do earthing. When I perform the process of earthing, electrons get removed and automatically I am left with positive charge. So this was my goal, to make the isolated sphere as what? As positively charged. Understood, Gauri? Is it clear to you? Okay, he's having issues in audio. Gauri should try to rejoin. Okay, he's having issues. Gauri, is it audible now?
Yeah, it is audible. I was
It
having
is audible.
an issue.
Okay, fine. Now, see, properties of electric charge. So we'll do basic 3 properties of electric charge today. The other property of electric charge, that we'll do day after tomorrow. That involves your numericals, and your numericals begins from that property. But right now, the first property is additive nature of charge. Additive nature of charge means what? That the net charge on a body can be calculated. If I give you this example where a body has +2 coulomb, +2 coulombs, +3 coulombs, -1 coulomb, -2 coulomb. If I have such a case, now if I want to calculate the net charge, since charges are what? These electric charges, these are scalar quantities. Scalar quantities are what quantities? These are those quantities which have only the magnitude. They do not have the direction. So charges are scalar quantities. Now, if these charges are scalar quantities, it means I don't need to find any direction of electric charge. If I know the electric charges, magnitudes or values, I can easily get the net value. See, when we'll be discussing electric force in the next class, most probably when we'll be starting with Coulomb's law, then we'll see electric forces have direction. When we'll do electric field, then we'll see electric fields have direction, and we cannot add all these quantities randomly. But since electric charges, these are scalar quantities, these allow themselves to add algebraically. So net charge on the body is the algebraic sum of the individual charges. Means plus 2 coulomb, plus 3 coulomb, minus 1 coulomb, minus 2 coulomb. So this gets cancelled and I'm left with 2 coulomb. It means I am able to get a net charge on the body. Net charge is coming as 2 coulomb. So this means additive nature of charges, that charges allow themselves to get added algebraically. The second property is that conservation of charges. Now, charges cannot be created nor be destroyed. Reason is that we have already studied that it is the transfer of electrons that occur. It is not that any body gets excess of charge that makes it as negatively charged, or any body gets excess of positive charge that makes it as positively charged body. What did we study? We had studied nuclear forces do not allow protons to move. Electric forces allow electrons to move. So it is the transfer of electron that keeps on changing. But if you keep calculating the net charge that is there, that will be the same, no? It's only one has more electrons, other one has lesser of electrons. That makes one as negative, other one as positive. So this is known as conservation of charge. Conservation of charge means what? Charges can neither be created nor be destroyed. Only charges get transferred. And in the charges also, we have specifically electrons that get transferred. So transfer, if a body has 3 coulombs, other body has 4 coulombs, or let's say other body has 6 coulombs. If from 3 coulombs you are transferring 1 coulomb, this will be having 2 coulomb, other one will now be having 7 coulombs, but the net charge will remain same. That was initially, it's only one charge that has transferred. So this is the second property, conservation of charges. And the third property, before discussing this quantization of charge, quantization is a bit lengthy, so for that we require the next class. But invariance of charge, let us discuss. Invariance of charge means what? That charge does not depend on the speed of the body. Let me show you how. If I say I have a vehicle that is moving with initial velocity 3 meters per second. This is the case that I have given to you. Initial velocity of the car is 3 meters per second. Now, the charge on this car, the charge that this car carries, let's say this is 4 coulombs. Now, somehow, by some means, what happens? That the velocity gets increased. Means whatever is the final velocity, this is greater than the velocity of it. So let's say this is now 5 meters per second. So since the velocity has increased, charge should also proportionately increase. But this is not the case. Charge is independent of the speed. Even if it is 3 meters per second, charge is 4 coulomb, or if it is 5 meters per second, charge will still remain 4 coulomb. This is what is known as invariance of charge, which says that charges do not depend on the speed of the object. Not depend on the speed of the object. Charges basically depend on the additive property, means if electrons are getting transferred, then the charge will increase. If electrons get removed, then the charge will decrease. But charges are independent of speed. Whatever be the speed, it is not a matter of concern for the charges. Are these 3 points clear?
Yes, ma'am.
Okay. So see, we have the fourth point as quantization of charge, the last property. So since we are lacking of time, we'll begin with that in the next class. So first note down these properties of charges.
Done.